Hello everyone, so now we are going to learn the mechanism 8, which is the bimolecular nucleophilic substitution, SN2. And SN2 is a very important mechanism in the haloalkane chapter because a lot of compound can be formed from haloalkane through this mechanism. For example, the haloalkane can become another haloalkane, alcohol, ester, ether, or amine. And then SN2 will be used when we have a primary reactant. For example, in this case is a primary haloalkane, and the reaction always starts from the backside of the product. And for the mechanism SN2, we must write our answer in 3D form to get marks. So look at this example, the conversion of 1 chloropropane to 1 propanol. In the first step of this reaction, the lone pair on the hydroxide ion attacks the electrophilic carbon in the 1 chloropropane. This attack occurs on the carbon atom that is directly bonded to the chlorine atom, and the 2 electrons from the hydroxide ion are pushed towards the electrophilic carbon atom from the backside. The left side is equal to the backside. While the hydroxide ion attacks the carbon atom, simultaneously the sigma bond between the carbon atom and the chlorine atom are broken down, and the 2 electrons from the sigma bond are pushed towards the more electronegative chlorine atom. And you may notice here, this process is a slow process because SN2 reaction is a single-step process where the nucleophile attacks the substrate and the leaving groups leave simultaneously. And this mechanism requires the formation of a high energy transition state. So the high energy barrier causes the process being slowed down. Thus, as the hydroxide ion approaches the carbon atom, it starts to form a new bond with the carbon atom, while simultaneously the bond between the carbon atom and the chlorine atom is broken down. At this stage, the carbon atom undergoes a transition state where the bond between the hydroxide ion and also the chlorine atom is partially bond. We represent it by using dotted line. And to represent the molecule is in transition state, we need to draw a bracket like this, and don't forget to draw the double dagger symbol here. This symbol is called double dagger. So finally, the leaving group, the chlorine atom, completely dissociates from the 1 chloropropane, and a new bond is formed between the hydroxide ion and the carbon atom. This results in the final product of 1 propanol, where the chlorine atom has been replaced by the hydroxide ion. And this process is a fast reaction because the transition state is very unstable. So finally, an inverted product is formed due to the backside attack. Remember, backside is from the left, and we get the final product with all the elements on the right side. That's all for SN2. Thank you.